Hello, everyone. Thanks for joining the IFAC Industry Connect webinar, which is a part of a series of webinars organized by the IFAC Industry Committee with the aims of increasing the engagement of industry within IFAC. My name is Kai, and I will be the moderator for today's panel discussion. So today we will go through different three sections. The first one is we will give you a little bit background introduction and share the experiences about different benchmarking problems. And then we will, based on the experiences, discuss how we can promote the industrial benchmarking and what type of best practice we can help out the actual problem to make better engagements. Then finally, we will go for a Q&A session. And here are some administrative details. So the audience will be muted, and please use the question tab to put in questions, and we will try to answer the questions at the very end. So first of all, let me introduce or begin with the industry committee and what we are doing. So the IFAC's industry committee is a subcommittee of IFAC. And IFAC is the International Federation of Automatic Control, which is a multinational organization, focuses on control engineering research and the impact of control technology on society. Within the IFAC, the industry committee aims at strengthening the engagement of industry and industry's representatives within IFAC and try to enhance the value of advanced control to the industry. And we have been helping out to organize different events like webinars and conferences and workshops within different topics to support these activities. And these activities are organized all over the world. IFAC Industry Committee has different activities to achieve the aim. And what we have been doing, including the benchmarking for industrial control practices, is just one of the series of the task forces to enhance engagement. And specifically focusing on the benchmarking problems for industrial control practices, what we want to do is to establish an effective way to bridge the control society with the industrial control problems through different problem setting ups. For example, the benchmarking problems can help us with identifying and publishing and organizing different types of problems and try to define the actual solutions for them, and then probably support the industry development based on the development of advanced control. Here, there is a very good example of how good benchmarking problems or definitions can support both industry and academic. I'm making an example about control benchmarking problems, which is published together by academic and the Airbus as well. And this benchmarking problems has been promoted over 70 publications as a direct outcome, and the researchers has been contributing within different conferences, and the industry has brought in the advanced control theory into their actual control problems and supports the development of the real world problem solving. However, there are still different problems that requires a society to work together and to promote it. And today, I'm going to start with some panel discussions and try to let the experienced panelists to introduce themselves and introduce their experiences about how they can share good problem definitions to support the industrial problem solving. And today we have three panelists. The first one is Mehmet, and Mehmet is an associate professor in autonomous industrial systems at Imperial College London. Before going to Imperial College, he worked at ABB in different research and development roles. He developed different model predictive control solutions for gas compressors, which is the technology that underpins reliable pipeline control for neutral gas from Norway to many European countries. And now, Mehmet has been joined as an academic, and his research is motivated to address challenges in process systems engineering with applications spanning energy systems, manufacturing, and industrial decarbonization. So the research focuses on development of intelligent, adaptive, and autonomous systems for operational chemical industry and also energy industry, combining different methods, including optimization, control theory, machine learning, and different things. Let's welcome Mehmet.
Hello, thank you, everyone. Thank you, Kai, for the introduction.
Thanks, Mehmet. So the second panelist is Peter, who is a senior control system engineer at Goldwind, Denmark. So Peter has been working at different roles, both in academic and industry. So before joining the industry, Peter was an associate professor at Aalborg University, where he held research role on model predictive control and fault-tolerant control with different industrial partners. And his research was getting into operational systems as well, and including wind turbines, for example. And later in industry, Peter has held senior research roles or engineering roles at KK Electronics and Vestas Wind Systems, where he contributed to the redesign of pitch control systems and wind turbine simulation tools. Since 2016, he has been a senior control system engineer at Goodwind Energy, where he works on advanced wind turbine and wind farm control systems. So his research has been contributed significantly in the field of fault-tolerant control, including creating benchmarking models for wind turbine systems for the fault-tolerant control problems they're in, and organize different competitions on these different problems. So let's welcome Peter.
Well, thank you. Welcome, everyone, and thank you for the introduction, Kai.
Yeah, thanks, Pete. And the final panelist is Martin. Martin is an associate professor in the Department of Electrical Engineering from the University of Eindhoven of Technology. His main research interests includes the measurement and data-driven modeling for nonlinear dynamic systems and linear parametric varying systems using system application methods and machine learning methods. And he awarded Flemish fellowships and European Marie Curie fellowships before, and also he was awarded a European Research Council starting grant in 2022. So mainly focusing on the benchmarking problems, Martin is one of the organizers of a benchmarking dataset initiative that promotes the use of common datasets in the development of data-driven nonlinear systems modeling and dynamic systems identification. Let's welcome Martin.
Thank you for the introduction, Kai. Happy to be here.
Great. So thanks, everyone, and welcome all the panelists. So the next session is several slides that we will introduce the different practices from the panelists and experience sharing about what type of problems they have been facing in terms of the benchmarking for real-world challenges. So the first session will be given by Mehmet.
Thank you, Kai, again. So the title of my section is Benchmarks from a Process Systems Perspective. If you can move to the next slide. Yes, so my background is process control. So process control has been traditionally a more applications-driven field. So that's why benchmarks are important for this field to bridge academia and industry. To give an example there, for model predictive control as a computational approach to solving complex control problems, this emerged out of the process control field and emerged from the industry, essentially. In this field, a key development was the introduction of the Tennessee Eastman challenge process. Interestingly, this was also a benchmark problem introduced by the industry. So the title or the paper is stated there, a plant-wide industrial process control problem. This paper has 3,800 citations at the moment, and it was impressive. So the original need was actually from the industry to come up with multivariate control approaches, how to pair manipulated variables with controlled variables. And they provide the nonlinear first principles model in the form of a Fortran code. And also I wrote here from the paper where they were saying how they are going to share this benchmark, right, using floppy disks and perhaps sending electronic mail, which was very new at that time. So this shows how things have changed. But if you go to the next slide, Kai.
Yeah.
So this benchmark problem was really very influential, and initially it was used for the intended purpose, the decentralized control designs, very quickly also to test model predictive control approaches and nonlinear model predictive control approaches. But in process control, we have different needs. Under, like I say, the control umbrella, right? IFAC is, the C is for control, but under this umbrella, we have many other things, right? We have system identification. We need to build models to build model-based control solutions. We have state estimation, which also developed into soft sensing, for example, in our field. This is also something where benchmarks are needed. Real-time optimization, economic optimization, or economic MPC, these are more about selection of operating points, selection of set points for the controllers, and how to run the systems economically in the most profitable way. But there is also statistical process control. How do we detect faults? How do we find the root causes of the detected faults, and so on? And more recently, we are seeing applications of machine learning, both for data-driven modeling and system identification, or model learning, if you want to call it, but also for active learning using Bayesian optimization or reinforcement learning. And eventually, we are moving towards autonomous systems. And surprisingly, the Tennessee Eastman benchmark was used for many of these cases. So it was even used beyond the intended purpose. So if you go to the next slide, Kai. So we are also trying to contribute to this. We were looking into how we can use machine learning methods and how to actually make the model learning process autonomous. We wrote a paper, and there we compiled a number of problems from the literature. And in our paper, which you see here on this slide, you can find all these models. And in the next slide, you will also see that with our collaborators, we made some of those models available as a gym environment for reinforcement learning problems. So this is also available now, where academics and practitioners can take these systems. They're in the form very suitable for building reinforcement learning applications. So this is also something we are doing. And finally, the last thing I want to talk about is again something we have done, where perhaps regarding the nature of the benchmarks, we are talking about systems. So we don't just have regulatory control. We don't just have one layer of control. We have actually layers and layers of control organized in different hierarchies. And here in this particular, again, training environment we proposed for testing autonomous agents is a system where we have many of the controllers and safety systems that will be in place. So this really takes everything from regulatory control to interrupts that will take safety actions, including operator behavior to highlight how humans actually also interact with the system, sequence control, and so on. So because in the end, wherever we put the agent, as we highlighted there in this figure, it needs to be actually acting, and it will have interactions with all these systems. So, and we want to showcase that work being done needs to consider all these different aspects as well. So let me stop there. I don't want to take too long, but during the panel, I'll be happy to answer questions on these.
Okay, thank you, Mehmet. So the second part will be given by Peter.
Yes, thank you. Please change the slide. Yeah, basically what I want to talk a bit about is this series of benchmarks and competitions on them we launched together with different other partners back 10 years ago, and all the experiences gained by those. And it was on the wind turbine and wind farm control for FDI and FTC, so fault tolerant control and fault detection and isolation. And the format was like we originally had defined this benchmark model and made that public available at a conference, and then called for a competition where solutions should be submitted to us for evaluation, and at the same time they were going to submit a paper to an invited session at that specific conference we identified. And then we evaluated the results based on performance requirements. Like in this benchmark on a wind turbine, you can see to the right corner, we had a number of faults occurring, and in the defined benchmark, they were occurring at specific times, but we were like shifting them in an evaluation to check like they were not hard coding in times into their solutions or something like that, and also put in some variation in some of the parameters to ensure kind of a bit robustness to the model. And then basically they were evaluated, giving a grade based on how good they are detecting and isolating the faults, or in the control part also to compensate for them. And then we at this specific conferences we had basically awarding the prizes for the first, second, and third prize, which had this like it made a lot of focus on it in the fault detection, isolation, fault tolerant control environments. And you could see typically it was a professor with some PhD students for different groups where the PhD student was doing the actual work. It was also said that this problem was not so large that you would need to spend many months to solve it, but like probably a month or two was enough for a good PhD student with some support to actually come up with a solution for it. And then you could really see when we were awarding the prizes, like these professors were really excited, and also kind of, especially if we could beat some of their good colleagues, or like if they had this opportunity. And then basically they'd also give some support for the PhD student. And these prizes were funded by the industry. Yeah. So if you can go to the next slide. And just to sum up, like we had the different events going on. The first one was on wind turbine fault detection, and was where the results were shown at the IFAC World Congress in 2011. Then we had the second one for wind turbine fault tolerant control at IFAC Safe Process in 2012. Then we had a collaboration with like an extended model for FDI and FTC of wind turbines, together with at an American Control Conference. And then the final one was on the wind turbine part, wind farm part, like at the IFAC World Congress in 2014 in Cape Town. And I listed just the collaborators on all these things, working together with Peter Mosterman, Michel Kinnaert, Jakob Staupstrup, and Catherine Johnson, and Sid Shafi, at different levels, and did these different competitions. And like the sponsors, prize sponsors were by MatWorks, and my former employer KK Wind Systems is named now, and at that time they were called KK Electronic. So it was like a co-work with a lot of people, and also facing different levels of involvement from the conference, where we were kind of tolerated at some, and at others we were having the prize ceremony at the conference banquet, which were occurring at the Safe Process in Mexico City. So it was kind of a smaller event, you could say. So I think at that time we were kind of pushing a bit to how academia viewed on contributions. It has been open quite a lot more now, and I can see it to the next World Congress. There is actually an official benchmark competition running there. And at that time we were doing this was kind of a new thing to do. There were, of course, benchmark models around, but they were not like competitions, and in that sense, if you can just put to the next slide. Yeah, you already done that. Good. So some of the things is learnings from this is like how to make a good, robust benchmark from a company point of view, where you are not revealing all the company secrets. So you can say you need to be able to take them out afterwards, the findings, make them relevant for yourself. And also another thing is to do this advertisement and also secure sponsors for if you want to do this competition approach with it, which were important and draw some attention to the benchmark, and also like organizing the invitation and all these things, and evaluating solutions, checking that there was no cheating, hard coding results into it, for example. And then I think the thing I was most nervous about during this work, except from also ensuring that actually somebody is submitting solutions, there was like the top 3 papers or solutions. Their affiliated paper was also accepted for the conference we were having using as an event for our competition. That luckily happened all the times. We were not in a case where we have a prize winner which has not made a sufficient good paper for like being accepted at a conference. But these 2 processes was completely independent, so there was no syncing on that. So we could eventually come up in a scenario where we had the winner not being accepted at a conference, which also kind of raises the question also among us as organizers, like what is actually the best, what is the value of contribution to the environment, to the society? Is that a good solution model, like an implemented model with a solution? Or is a paper describing what you're doing? In our case, we're working in Simulink, so we said Simulink versus paper. And I don't think the answer is entirely obvious from a practitioner point of view, but from academia point of view, I'm not in doubt like a paper has much more value than a model has. But from industry, it's probably sometimes more different. Yeah, I think that was what I had to share with you. Last point I already mentioned about the like kind of level of embracement from the conference organizers.
Yep, thank you, Peter. So the next session and is a final experience sharing will be given by Martin. Martin, I'll hand it over to you.
Thank you, Kai. So yeah, I have a system identification background. So also my work in benchmarking has focused on system identification and especially nonlinear system identification. Next slide, please. So what we did, like almost 10 years ago now, is to set up a workshop and later on also a website where we collected a set of curated data sets and simulators for nonlinear system identification problems. And so right now we have 13 data sets that we feature. You can see them here on the slide. And they vary from scope and level of difficulty, going from lab scale electronic systems to typical teaching lab setup like the cascaded tanks, to industrial scale setups like an industrial robot or the ground vibration tests of an F-16. And of course, when we work with those data sets, we have experienced quite some different ways of operating with them over the last years. Next slide, please. And next slide, please. So the first question, of course, is why do we think such a website was necessary? First of all, we wanted to collect some modern nonlinear system identification datasets. Historically, there have been other websites or databases that collected some datasets, like DAISY, for instance. But that one was constructed, 10, 20 years before this website was constructed. So it was getting outdated in terms of what we could measure and the amount of data we can handle. At the same time, well, making data sets available is not enough. We also wanted to provide a platform where we can report the results and store them such that they're easily accessible for further comparison, including some baseline results. And we also have been organizing a yearly workshop. Actually, the whole event started as a workshop, such that we keep on promoting the use of these data sets, because a benchmark is only useful if many people use it. Otherwise, it's just another data set that is available. And through that, we hope to also educate and disseminate also with a mini course at that yearly workshop. Next slide, please. So based on that, based on the experience we gathered also by the different level of traction and attention that the different data sets gathered, we started thinking, what are good benchmark data sets for nonlinear system identification tasks? First of all, we realized we needed standardized ways to access the data sets, such that you don't need to change the way you load the data for every different system you want to try your methods on. And secondly, as of course in the framework of this webinar, it should also be representative for challenges that are present in the field in terms of data set length, signal to noise ratio, type of experiments we apply. And then we want to compare results, so we need to have clear tasks and evaluation metrics, and clear tasks are required for comparison. And that's of course not obvious in system identification, because the goal of system identification is to have a model, but the model is most often not the end goal of a whole control process. The model is only a tool that is used as an intermediary. So we need to make some choices there, but at the same time we need to be open on other ways of quantifying the quality of a model, because there are many constraints that can be considered. So tasks should be aligned with possible end goal of the model, and we should be able to also present our model with those considerations kept in mind. So that comes also to the result interpretation. Comparisons requires nuance, and focusing on a single number might not be as good. That might create an over-focus on benchmarks and not on solving actual problems that are present in the field. So result discussion remains key there. And then, well, final thing, having baseline results, please, previous slides, please. Having baseline results is important, because otherwise new people that arrive and start to work with those benchmarks, they have nothing to compare to. And well, we have seen results being submitted that were doing worse than a linear model, while they claim to have state-of-the-art nonlinear identification results. So we should make sure that we have good baseline results and good reproducibility. Next slide. So what do benchmark create impact? To summarize what I mentioned before, we need to have an appropriate difficulty level such that it's easy to access and it doesn't require a year of a PhD to get reasonable results. The data should be accessible, and of course, more than one approach needs to be able to give good results on the benchmark, because otherwise you can't really start to compare approaches. And finally, good documentation such that there are no hidden challenges and that people can understand the physics behind the actual system they are working with. Next slide. So how can we then move forward? Some thoughts, final thoughts from my side. What's the responsibility of the field? Well, making curated benchmarks available. Too much is also not good, because, well, if we have a sea of benchmarks, then we can't find anymore the nice or the nice elements to compare with. We need to promote benchmarks, so we need to keep on organizing focused invited sessions, workshops, discussion groups, to make sure that we keep on discussing and disseminating the results and the conclusions that come from the comparison. And we need to publish code plus examples. That's an example that we have gotten from the machine learning field, and there is a nice control systems magazine paper that actually highlights how little we publish code and make our results openly accessible in the control field. So that's really something where we can improve. And that's something that reviewers and supervisors can also take action for. So when we review a paper, we should ask for published code. We should be critical on how they compare results, and without losing, of course, appreciation of one of the strengths of the control field, which is also the theoretical contributions. So we should not only focus on benchmarks. And with that, I would like to leave you with these thoughts and give the word back to Kai.
Right. Thank you, Martin. And now we finish all the experience sharing from the panelists. And the next session will be having some discussions with all the panel members to share some more in-depth observations about different problems. So I will stop sharing now and start our discussion sessions. So as the discussion before, it seems that, and it is sure that, great benchmarking problems can benefit both the industrial practice and academics research together. So would you be able to share any problematic experiences that stop great outcomes from happening in your past experience? Peter, do you want to mention anything?
Yeah, it's a bit there. Something I already talked about in my short presentation about this. You can say dilemma between the solution and also good paper, which Martin also mentioned about. Like in controlling the community, we're not used to code implementations, but just the theoretical description of the solutions. And I think that that's actually a good point to make also from industry point of view. Like we need to see how solutions are made and not just like the theoretical implementation of it, because there is always something which is entirely as in theory. There are some smaller cuts here and there which are important. So that thing is, it's important for industry. When we do this kind of collaboration, we're actually sharing how to do it, and also think about how can we actually require this information when we're doing academic publications.
Yeah, thank you, Peter. So how about Martin and Mehmet? Do you have any observations and comments?
No, I completely agree with what has been said, and I think accessibility plays a key role on one end. So as Peter also mentioned in the presentation, we as a community needs to be open to accept also papers that focus on benchmark solutions, not necessarily having the most theoretical contributions, but then also the benchmark itself should be accessible, which means that you might need to make trade-offs. It doesn't need to solve the full industrial problem at once, but if we can make a benchmark that only pinpoints aspects of the challenges that require solving, and like that keep the complexity of the benchmark under control, that allows many more methods and allows for much less time that needs to be spent on solving the benchmark. So instead of spending a year, maybe a PhD student needs to spend a month to generate good results, which will generate much more contributions. And if you have more contributions, you have more creativity that's going around.
Yeah, thank you. Thank you, Peter and Martin. So it seems that solution itself is not simply to let academics to understand what the real needs are from the industry, and defining the right levels of the problems and communicate it is quite important. And then it's the same for the academics to communicate back to the industry as well. So one other issue that we all heard is that academic solutions are sometimes considered not very useful for industrial practices because the solutions are developed on top of many assumptions and simplifications. So have you faced similar problems from your observations? Mehmet, do you want to comment on this?
Yes, I think the previous discussion was also pointing a bit to this, right? If the benchmark problem is very complex, it's very difficult for perhaps a PhD student to really get familiar with all the aspects of the problem at hand, to make a meaningful contribution, to come up with meaningful results that can benefit industry, but also can be published and can benefit academia and the readers of the articles they publish as well. So this is indeed a challenge. So I think another aspect here I think is there has to be collaboration. So I think we have to work and agree on which benchmarks are good benchmarks. And so with this example I was giving, Tennessee Eastman problem, it was available. It attracted a lot of attention. So, and the more people worked on it, the more follow-ups were there. And then people can compare, people can see what are the ways of defining problems, scenarios, and so on, and how to then also compare the outcomes. So I think this needs to be done really carefully to be able to really benefit from the benchmark problems. And this is only possible, I believe, if the problem has a certain level of complexity. So I think this is something to think about. And I believe here also we are also coming to a point where, for example, benchmark data set. So the data set in that sense is not enough. So if we want to run scenarios, then we also need to be able to simulate. So we need to have we need to have the model there as well, an ability to test. So these are, I think, things that are playing a role. And there has to be a certain level of realism how to manage this. This is, I think, where there are opportunities to get more work on benchmarks for this community.
Yeah, thank you, Mehmet. Martin mentions that the problems should be simplified enough for PhD students to work on. But on the other hand, as an industry member, my thought is we probably need to make the problem complex enough as well. What do you think about this, Martin?
Yeah, so I recognize this trade-off that needs to be made, and clearly that's also a moving trade-off. Like the complexity we could deal with 10 years ago is different from what we can deal with right now. And the tools that are now automated compared to what we had 10 years ago are also better. So that shows also that benchmarks should be updated, or at least we should change our idea of what a good benchmark is in our field. Over like something from 20 years ago maybe is not relevant anymore. And that we should make sure to highlight that. And a way we can deal with that complexity is maybe like if we provide reference solutions for the complex problem and we make that in a fairly modular way, then people can attack subparts of the complex problem while having still the full complexity available. So we can also modulate complexity by how much information and how much part of a reference solution do we give already available for the students to then build on further. And that reduces the threshold to start working with the problem. But I think keeping that threshold low enough is important to keep successes or keep engagement realistic.
Yeah, thank you, Martin. How about you, Peter? Have you got any observations on the complexity and the simplicity of the problems?
Yeah, a bit like the other two guys have said, but also from the industry point of view is like systems are complex, of course, but quite often a lot of the complexity is maybe not so important for the actual benchmark, but you need to focus on specific issues, areas in the system. But also knowing, as we know, what is where the intersection or the cross correlations is with other systems. So you know, like if you change this part of the real system, then the risk is something else is happening in another part of the system. Like you combine this information into like tailored models for for different problems. So a subset of the real system, like full complex system, but just a subset of it. But where you still have the complexity, just on a smaller scale.
Yeah, thank you, Peter. It seems that it's very critical to define the problems in the right complexity and balancing it. So apart from the problems about complication and effort for replication, do you feel that there is any other important consideration while working out or publishing a benchmarking problem? Martin, do you want to begin with? Because you're maintaining a data set.
Yeah, so well, there are different complexities. So first of all, when we work out a benchmark, well, accessibility, we've briefly touched upon that. That's one of them, but that also means that, well, simply storing the benchmark, the documentation of the benchmark somewhere such that it's available. Well, you see the example of the Eastman Tennessee benchmark. Well, that's been around for decades now. So that means also that we need some central storage and a central access point where the original version of the problem is available that everybody can get back to. So that's also not, well, it was not trivial in the past. Nowadays, we have storage offered by universities or by research organizations that can take care of that. But it's something we need to, well, be aware of, that, well, it needs to be stored in such a secure location, and the format files that we use should also be something that is robust towards change of software. If we were using a certain file format in the past, well, some file formats have changed and are not accessible anymore. So for data, for instance, well, we can use easily accessible formats, .mat if you're working with MATLAB, .mpz maybe if you're working with Python, or you can also use something very, very basic like a .csv file, which is, well, is commonly readable by many platforms. But those things need to be taken into account, and that's only for data. Imagine you have a simulator, then things become much more challenging, because you need to run code, and legacy code is a very difficult thing to handle. So that's definitely an important issue. Like, how do you keep those files in a format that is easily accessible?
Yeah, thank you, Martin. You mentioned storage and the format. Mehmet, how about your experiences? Besides this, what else do we need to pay attention?
Yes, I mean, I think this is, I'll keep commenting on the same, because the simulating dynamic systems wrapped with control algorithms, this is actually not so straightforward. And what I see is that industry still puts a lot of work in this direction, and not only to create the problem, but they actually have their solutions, and they're testing, for example, with hardware in the loop simulations, with real-time control applications, and so on. And what would be best is, of course, to have an extract of whatever that can be shared, let's say, given IP restrictions and so on, shared with the community, and this is going to be the challenge problem. But then what do we do with the simulation environment? I think that's when it makes the most sense. But as Martin said, it's very difficult to keep up with the changing formats, changing requirements for running the systems, changing technology. There is also the open versus closed systems aspect, right? The simulation environments tend to be closed at the moment. There are some open ones which are perhaps not at the same level, and maybe also not as used by the industry as well. So how to share it is indeed a challenge, how to maintain it. Perhaps also is important to really have very good descriptions that are when we publish, that it can be built from the ground up. So it's very well described in documents that people can again build the simulation. But this is, I also understand this will be a lot of work. And again, an open challenge, something to think about. The perhaps consortium, some way of collaborating on maintaining, having benchmarks instead of different groups working on it individually. When a PhD student leaves, you have difficulty finding a way to keep supporting the available benchmark. Perhaps if we can join forces, we could do better in maintaining fewer but higher quality benchmarks that are relevant for the whole community.
Yeah, thank you, Mehmet. Peter, do you have any comments, observations?
Yeah, well, I can agree quite a lot what they Martin and Mehmet have said about the maintenance and storage and accessibility, and especially the maintenance part is an issue. If you are still getting like if you haven't maintained that over several years, then it's difficult to keep it updated, and also like if it's running with an old software system or language, it's difficult. Also, when you start working on it, it's hard to say what is used in 10 years in terms of coding language. And what is like, so you need in a sense to have a way to make it maintained on the fly as it was a commercial product, and that's difficult when you do it like as a part of a story or whatever, a project, and then over the time nobody's working on that anymore, and somebody just needs to keep it updated unless we organize it a bit more in a community, which could be a solution for it.
Yeah, thank you, Peter. So based on the former discussions, it seems that we majorly mentioned two types of problems. So one type is the data set, and the other type is the model of control problems. And the activities and the considerations are a little bit different in the two types of benchmarking problems. And I hear very interesting words from the discussions. One is about the maintenance. But on top of maintenance, Martin also mentioned about maintainability of benchmarking problems. Do you want to liaise with these maintainability issues more, Martin?
I think that I mentioned already those things. It's about accessible formats, making sure that safe storage, clear documentation. Yeah, that those are aspects that I mentioned already. Maybe what I can add on it is the way we can facilitate that even if you have legacy data that's in a different format, you can always write a wrapper code around it. Let's say a data loader, in my case, that allows you to interact with it using current state-of-the-art methods, or that automatically formats the data in a way that it is useful and comparable to the current state-of-the-art in the field, or the current good practices in the field. So that's a way to overcome some of those difficulties, writing wrappers around it. But again, they need to be then maintained and stored and made accessible, and everybody needs to use the same. So the same problems stay present.
Yeah, thank you, Martin. And also, Mehmet has been working on modeling of benchmarking problems at different complexities as well. Have you faced any problems about maintainability of very complicated models or the industrial problems before?
Yes, I can give you right away an example. So when I was a PhD student in the research group, we had a complete pulp mill factory, the simulator for a complete pulp mill factory, and this was available as a MATLAB Simulink formulation. And I took a look at, running it. It's impossible to run it at the moment. It's going to be a long work to, update all the dependencies to get this working, because it has hundreds of files in there, and because it's a, large scale system, that it's a network system that's all connected together. So it's beautiful as an example. It captures all the industrial reality that is there, with the different control loops, with the dynamic responses of the actual systems, validated with data from actual pulp mill. But yeah, how to do this is indeed a challenge. So the higher the complexity, the closer you are, but the bigger these challenges are. And I think these are not going to go away. Instead, it's going to grow, because we are branching out. We have machine learning, we have AI. We are discussing, for example, having a benchmark on the operator assistance systems. If you have a number of engineering documents around operations, around control solutions, and how can we have an AI system that can assist an operator with an ongoing fault? So we can build these systems today, but we are thinking of having a benchmark problem with the different documents that are related to a system. So this is now branching out even further than just system identification data sets to simulations. Now we are discussing even broader systems. So how to do this is we are working on it, but I think also as a community we need to discuss. Perhaps the IFAC Industrial Committee can also facilitate or play a role in how we get together to collaborate more on benchmarks.
Yeah, thank you, Mehmet. We should definitely collaborate and work out the solutions together. So one thing still pops up in my mind is because Martin has been organizing the data set access before. But when I was looking into a problem, I was searching for benchmarking data sets for industrial robots, and I tried to do some system identification myself as well. But then the data set provided by Martin was not appeared by Google search at the first sight. Accessibilities to benchmarking problems still seems a challenge. Have you got any observations on this, Martin?
Yeah, I think that's about continuously promoting and organizing ourselves around data sets such that to become a benchmark, they need to be widely used. Otherwise, it's not a benchmark, it's just a data set, or it's just a simulator. So it requires a constant effort in organizing invited sessions, organizing workshop, organizing events like this to put these efforts in the picture. And of course, that requires then when you set up such a benchmark that you know that it's accessible or that many people in the field can work on them. So they're sufficiently rich or sufficiently relevant for many people, because otherwise they will never get traction. So it's always good to also discuss with multiple people in the field, even when you're only doing the effort in creating the benchmark. Discuss it with other people, get their opinion, because it can help you in fine-tuning the problem and the accessibility of the problem, such that more people can use it.
Yeah. Thank you, Martin. How about you, Peter? You have organized different competitions. Did you face any problems about accessibility before?
Yeah, actually. Like the issue was like when I started these competitions up, I was employed at a private company, another one, the one I'm at now. And that time they actually want to host the model to draw some attention to it. And then the problem was like at some time I was my employment there was terminated. And then we basically need to change to another location for sharing the model from, which were Aalborg University, my former university. But then at the same time, you can say, like need to make people aware, like now it has a new location. And at least know I was contacted by some people, like they couldn't find the model anymore and helped me to the new location. But that's a problem when you're not like whatever kind of linking to the model, if that's not the constant. If you put in links to it and the link's not working anymore, even though it's still the same place, but just get a new filing system, address system, so it's have a slightly different name, for example. There's a lot of these kind of small practical issues. Yeah.
Yep. Thank you, Peter. Do you have any comments on this, Mehmet?
I think it's well covered. I really like Martin's comment there before on, it's not a benchmark if it's not being used by people. So I think that's something that really reflects that just putting out a model or a data set is not good enough. It really needs to be out there, findable. Like you say, if you do a Google search, you should be able to find it, and people should be publishing on it. I think only then it becomes a true benchmark. And I think the events, conferences, webinars like this, I think they will play a very important role.
Right. Thank you all. I think that's paying attention to the time. I think we need to stop the discussions, and the next session would be getting questions from audience. And I personally haven't seen any questions raised by the audience yet. If you want to, please try to type in questions. But before anyone typing in other questions, one interesting thing I want to hear about or discuss with everyone is you mentioned a lot about letting PhD students to work out the benchmarking problems. And what if the PhD student leave the group, and how would you continue your research stream? Do you have any answers to this?
Well, I think it's all about benchmarking problems. You can work on the problems. I think working out the benchmark, senior staff should play a significant role in there, because we have a different overview of the field and of what it means to have a data set that can be accessed by different methods. Of course, when it's developed by PhD students, it's all about documentation, commenting, and modern version histories to keep track of maintenance of the scopes and make sure that there is clear handover on when people leave. But I think that's a problem that we face in all research projects where we want to build further upon. We see similar problems there.
I think if I could comment, I'll say ideally the benchmark problems should come from industry. So those who really are looking for solutions to their problems. So I don't think it's up to a PhD student to come up with a benchmark. So I think it has to be. I mean, there has to be a good foundation to why are we doing that benchmark, and I think if it's successful, I don't see a big challenge in having a continuation of PhD students that can actually still support, and of course academics can also play a role. I see that less of an issue. I think it's more getting a good benchmark, having the interaction with industry, having this bridge. That's I think what matters more.
Yep. Thank you all. Because we didn't capture any burning problems at the questions from the audience. But the video will be shared through YouTube and the IFAC official channel, so we can keep hearing questions from others. And I think this is the final touch for the Q&A session. And before we finish everything, I want to mention the upcoming activities or what we are doing at the moment to promote the industrial control problems. And firstly, Martin and Peter are serving as guest editors in the IFAC journal, Control Engineering Practice, and they are organizing a special issue on benchmarking control applications. And the deadline is in the November end. So if you're interested in submitting any papers, please feel free to submit or just reach out the guest editors for discussions. And the other advertisement is the IFAC Industry Committee. has been invited to contribute to the IFAC World Congress in Busan 2026. And we are going to organize activities about benchmarking for industrial control practice. And the type of the event is still in discussion. But if you're interested in joining this session, please scan the QR code on the slide, and we will collect your interest and contact you later. So that's the very end of this webinar. Please let me thank everyone's participation, and especially our panelists. And thank you for experience sharing. And this is the end of my word.
Thank you, Kai, for organizing it and for having me.
Thank you very much.
Likewise. Thank you.
Yeah, thanks, Kai.
Thank you, Peter. So I think, thank you, everyone. And I think this is the end of the webinar. We will close this, and this video will be edited and shared through the IFAC official channel. And let's stop the session.